Okay, we can start. Good afternoon to everyone. This is as I told before, this is the last half day of our workshop. This afternoon we will have the last 6 presentations, 3 before the coffee break from companies and 3 after the coffee break from universities. Okay. My name is Alessandro Ascari and I'm a researcher at the University of Bologna. So nice to meet you. As you should know, I'm the last of the organizers you are going to meet in this workshop. I hope you had a refreshing and resting lunch, a good lunch, I hope. And so we are ready to start. We can start with the first speaker from the company Borg Warner. The speaker is Mr. Davide Spazian. Okay, Davide, please, the stage is yours. Please try to be in time, 15 minutes and 20 minutes the whole time with 5 minutes of questions. Please, Davide.
Good afternoon to everyone. My name is Davide Spazian. I'm working in Borg Warner as a charging account manager. And today I'm going to present you my company, product that we are doing, where we are focused, and going deeply in the local reality that we have here in Emilia-Romagna. Borg Warner is an automotive company founded in 1928 in Auburn Hill, Michigan, mainly involved in producing and designing internal components for automotive market, mainly IC. We are roughly 50,000 employees, and we generate a revenue of 15 billion last year. Being an automotive company, we are focused to be nearby our customer. That's why we have so many locations equally spread across Europe, Americas, and Asia, 22 different countries. Our vision now is a clean and an energy efficient world, and we would like to develop solutions that are innovative and sustainable for any kind of vehicle in the market. For being this, we have issued an initiative that is called Charging Forward. In this initiative, we aim to convert up to the 45% of our revenue in 2030 by product coming from e-mobility, internal component, and ecosystem around it. In parallel, we aim to be completely carbon neutral by 2035 and reducing by the half of the greenhouse gas emission by 2030. In parallel, being a global corporate company, we believe in our team and we empower our diverse. This is the organizational chart of my company. Is mainly divided in 6 divisions. Each of these divisions is focused on a specific market or a specific type of component. And you can see on the left the CEO of this division. All of them are led by Mr. Fred Lissard, who is our global CEO. On the right, you can find transverse figures that are helping this division to support and being accountable into their mission to bring, as I said, an innovative and efficient solution for the e-mobility. This is an overview on what we are doing. Each division, as I said, is focused on a specific type of product. We belong to the Morse system. And the Morse system, we are mainly involved in engine timing system, valve train, battery packs, fuel handling inverters, DC-DC, and battery charger. Let me give you a quick overview about my division. We have roughly 7,000 employees, same philosophy of the Borg Warner Group, so equally divided across Europe, Asia, and North America. We have several locations, tech center, sales, and productive centers. Each of them are specifically involved to design and to develop and to produce a specific product. This is our portfolio. As I said, and as you can see, there is the clear mission to convert more and more our offering from a pure combustion engine market toward hybrids, and finally to the electric market. In particular, we have included in our portfolio battery packs lately by the acquisition of a big company in Germany, and we are developing by our own charging station and power electronics. Here is the overview of the plant where I'm currently sitting in, that is in Lugo. We are mainly focused in produce battery charger for every kind of application of highway, on highway, low voltage market, high voltage market, and automotive. We have a strong experience in battery charging because this plant has been founded more than 40 years ago and started developing its first application for battery charging lead-acid batteries. And we started by the 2000 to develop our first application for charging lithium battery packs, followed by a requirement of our customers that are asking more and more of innovative solution. And that's why in 10 years later, we have developed our first battery charger specifically designed for high voltage battery packs. Last but not least, our latest product is the automotive fast charger that we have developed last year, and we have started to produce it, this one. And this is our first product that is aimed to enter in the market. Almost can be sold everywhere because of its characteristics. It inherits all the experience that we have on the battery charger side. So it's robust, it's reliable, but at the same time, it's capable to be installed on public areas, so it enables you a complete portfolio of market application. But this is the first sample of this product family. We would like to develop more and more of this type of solution, and I will explain you later. Quick overview about my product. The product is a 120 kilowatt charging station that is capable to charge two vehicles in parallel at 60 kilowatt. This type of solution is interesting because of the fact it is being designed robust and reliable. It's almost being able to charge any kind of the vehicle application. So I'm thinking like automotive market, passenger car, commercial vehicle, but also all of the vehicle that needs to be charged, and we see more and more. I know that you are cooperating with a battery company who has developed specific custom application for the industrial market, for example. And this type of solution can be easily fitting that market also. It's IP54, IK10, pollution degree 3. It's able to be charged, to charge starting from -30 to +50, up to 4,000 meters altitude. So actually it can cover every kind of application and location. Here you can see our mechanical design. As you can notice, the internal component and the internal design of our product clearly show its nature. It has been derived from an industrial concept in order to be considered robust and reliable. And most overall, the entire bill of material and the entire design is property owned by us, so it's completely built in-house. This obviously requires a specific development and capabilities, and that's why we have shaped our plant in order to being able to embrace either the industrial market and the automotive market. As you can see, a quick picture of our production area. In this area, we are able to make coexistent the industrial market with a production of roughly 25,000 chargers per year, and the production of this type of application with a production rate up to 1,000 chargers per year. So in total, we are able to embrace a big variety of different type of application. As I said, we own completely the design and the IP of this product. That's why we have our tech center, our development center in-house that is, as you can see, very near to the production area. And this is what we produce from the battery charger point of view. In parallel, we have a wide product range of inverter that are able to cover the low voltage market from 24 up to 96 volt, but also the high voltage market. So in this way, actually, and thanks also to the battery pack capability production that we have, we are able to offer a turnkey solution to our customer that are looking to integrate e-product and to convert their solution to the e-mobility. The product line of the inverter follow roughly our experience in the battery charging. We have been on the market with a Safcon brand starting from 1960 with our first application, and then follow again by the request of our customer. We have developed more and more solutions in order to compensate and to support their need. So starting from DC motor control, and then followed by the 2000, our first AC motor controller with PMAC, and then more and more application towards the automotive market by high voltage application, like the latest one. A quick overview and a glance about our power electronics markets. As I said, we basically the same footprint. We have a couple of products that are battery charger and power electronics, mainly developed and developed here in Lugo, that are moving in parallel to attack the same type of market. So industrial market with forklift, aerial lift equipment, airport ground center, marine, mining vehicles, but at the same time embracing all the automotive counterpart with application automotive and off-highway. And again, follow the same philosophy of completely have the IP and the experience and the know-how to develop solution in-house. We have our development center that is in the plant that is permit us to being nearby the customer and develop their custom installation, their custom product in order to fulfill the need. Thank you.
Thank you, David. Thank you, Davide, very much. You have been on time. Thank you. And any questions or comments, curiosities from the audience? I have one, just in your product portfolio, which is the product, in your opinion, that requires the higher demands in terms of technology, in terms also of manufacturing technologies?
We can say that both of the product line that we are developing are high technology demanding. If I think about the inverter and the power electronics product, their requirements are so strict that needs to be designed very carefully. They need to embrace higher IP grades, so they need to operate in harsh environment and harsh condition, because in the automotive market, you need to take care a lot of severe working condition. At the same time, also the battery chargers, because even if we are delivering commodities product, we in the end deliver a service. So in the end, our product need to last, be reliable, and doesn't cause any potential failure to the end user. So that's why we invest a lot in high tech. We invest a lot in development. We invest a lot in designing a solution that could be proof of any potential failure.
Okay, thank you. Other questions? Okay, if not, thank you again, Davide.
Thank you.
Okay. Okay. Second speaker of this first part of the afternoon. Now we have Giuliano Elena, okay, from Podium Tech. Please, Giuliano. The podium is yours.
Thank you very much. Good afternoon, everyone. First of all, I want to thank you for the invitation and congratulate for everyone involved in the organization in this successful workshop. It's been good to see that many other companies, they face similar problems, and laser OEMs and system integrators, they're bringing new solutions to solve them. First of all, I would like just to give you some of key facts about Podium. Podium is an engineering company based in Valle d'Aosta region. Has been founded in more than 10 years ago, and has a strong mindset in motorsport, hybrid system, and battery systems. So in the last 10 years, the company has continually grown, developing motorsport application for endurance competition, such as the 24-hour of Nürburgring and WEC, and has developed different battery systems. Just a few highlights of the last 3 years. In 2019, Podium has designed, developed, and built Delta Futurista project. Is a resto mode project for one of our customers. 2020 was the first battery system delivered for a railway application with all the challenges connected to that. And in 2021, has seen the debut of motorsport application, motorsport car designed and assembled in Podium for a WEC hypercar class. So the company is divided in 3 different business units. One, road cars, automotive, for design and assembly of a bespoke project. Battery systems for the design accordingly to the customer requirement of a battery system, normally a high-performance battery system with all the electronics attached to that. And then and then we have also motorsport and racing cars. Talking about the battery division, Podium has the proprietary BMS system developed in-house with software that it's completely integrated in-house, has possibility to develop custom battery packs, do testing, and battery manufacturing. Today we want just to bring you a little bit more insight on the steps between the requirement, the product, and how from the product we get to the selection of the process. That is such as laser, that is a key technology for joining. So everything starts with testing the cells, characterize the characteristic of the cells in terms of performance and in terms of thermal characteristic that they have during when they work. Then all this data, they are used to develop the battery system in terms of module, pack, and during the phase of the design, the design department strictly collaborate with manufacturing engineering to understand what's the best technology for adhesive or for the joining technology, for example, bus bar to cell. And because there is a strong interconnection, as we have seen in the last 2 days, there is a strong interconnection between the product and the process. And both of them they need to match each other's and they need to be developed together. Once that the battery is designed, we have the first build of prototypes, and in conjunction the development of the battery management system and all the software integrated. Then the system is validated, tested, emulated, depending on the characteristic of the application. Different tests are applied, and then once that the product is validated, battery production can start. So we talked earlier on about product and process and how the two items they go together. So in-house we have the possibility to do wire bonding, and it's a technology that can give some advantages, such as doesn't require any special tooling. It's give the possibility to 100% check the quality of the connection, but on the other side brings some disadvantages, such as thermal characteristic, heat that generates in the charge and in discharge, and the different other challenges. So laser welding, on the other side, can provide probably a more wide surface of connection, can accept charge and discharge cycles probably more aggressive than wire bonding, but bring some complexity in terms of process, development of the process, and tooling. So just going through one of the wire bonding application, we recently have introduced one in a very unique motorsport application with bespoke module, with cylindrical cells, and as you can see, there is no requirement for tooling, development of tooling, and it's less sensitive to the height and the manufacturing tolerances. So we have bus bar material in aluminum with cell material in steel and wire material in aluminum. When it comes to our experience in laser welding, we have had a couple of experiences in the last few years. One of them is with the prismatic cells for a urban light rail system. This application has been quite challenging, mainly because the requirement of the customer had a lot of safety attached that had to be taken care during the development of the product, the development of the process. So a lot of tests have been done, and there are, as we said, we had quite a strict join specification, welding specification. So in order to test the parameter, the welding development, a lot of tests have been done in order to sense check the temperature limits, verify the welding penetration, making sure that the electrical resistant targets they were within the limit, and then and also the mechanical requirements. Another application that has been developed recently is a motorsport application based on cylindrical cells. This application was really challenging in terms of charge and discharge rate. So it was quite a very energy dense module with a lot of power density, and as we said earlier on, we had a process of laser welding development that has been done, going through checking joint micrograph, checking the weld penetration of the joint with all the challenges that the can and cap weld bring, and then strict temperature limits, being very high performance cells. This has been quite a sensitive topic. And then electrical resistant targets and mechanical requirements have been checked. And then in order to validate the 360 degrees weld, CT scan has been done on several samples. So going through a typical laser welding development, starting from the development of the welding specification, we tend to select the right technology, then develop the laser welding parameters, and then do some tests just to make sure that power density and input control are balanced. We know that with bus bar and cell connection, the trade-off between power density and heat input is really key. So it's always good to find the sweet spot and making sure that the application can work correctly. So once that the parameters have been developed, there is a study on process window definition, just to understand how the application and how the technology can allow us to move from one position to the other within the boundaries of the limit. So then welding sputter generation, pull test, and resistance diagram, just to make sure that the two of them, they are interconnected in a graphic way. And then in the end, the joint surface cleanliness definition, and obviously all developed to the design of the tooling. Our next challenge is going to be try to scale up the production. The moment we have a limited production in terms of number, but we are now moving in a new, wider facility where there will be high level of flexible stations, allowing us to build different modules with different chemistries and different geometry form of cells. That will include also laser welding system, able to allow us to have good welds on bus bar and cell, and having all integrated in our machine with high level of flexibility. So the assembly area will be quite wide and with a volume around 2,500 packs per year. Thank you very much.
Okay, thank you very much, Giuliano. Very nice presentation. Some questions? Please, Johannes. The microphone is coming.
Thank you very much for your presentation. I enjoyed it a lot. I have two questions. The first one is concerning the temperature measurements. Where did you measure the temperature exactly? Like in the inside of the cell? Yeah.
We had on the two different projects, temperature measurement has been a really key part of the welding development. So the temperature has been measured inside with NTCs, and the positioning of them, we've seen a lot of variability, how it's positioned and how the results are. So it was a challenge, yes.
Yeah, I see. The second question is concerning the geometry of the weld seam. did you also vary the geometry, like making lines, circles with different sizes? And do you vary the geometry between different modules with like different sized batteries, or maybe also within a module, because the mechanical forces are maybe changing within a module, no?
Yeah, every application has its own challenges, and that leads the welding specification. So the requirements in terms of mechanical, probably some dots, they could be okay for certain application, but for the other, different shape or a different, more connection area can give advantages. Thank you.
Other questions, also from the remote side of the audience? No? Okay. If not, thank you again, Giuliano.
Thank you very much.
Okay. Last presentation before the coffee break. Now we have another company, Augmenta. Okay. We have Andrea Tagliaferri, if I'm not wrong, because there has been a change in the speaker. Okay.
Okay.
Andrea, please.
Hello. Hello, everybody. I'm Andrea Tagliaferri, the head of AI driving manufacturing department in Augmenta. So, let me talk about our vision and mission. We want to solve a complex problem with generative AI and cognitive manufacturing machines. We want to develop intelligent industrial machines, because to produce batteries or make some functional laser structuring on surfaces, it's very difficult. And we have a lack of skilled people to work inside the company, and we have a lack also of technology inside the actual manufacturing systems. So let me talk about the challenges in remote welding. This is a corner welding. I use it for prismatic cells. And when we deploy the process in the first time, you have certified materials, you have all the details that are okay, like the position in the space, the tolerances. You have checked everything on that batteries, but then the production starts and the supplier sends you different materials. The jigs used to fix the battery under the scanning head are not working well, and you get defects. You have a lot of defects you can find, and usually the system is not able to find it in time and prevent, to avoid any quality drift during production. In another case, we have a more difficult application, because the fiber laser is well known that is not the best friend of copper. And in copper, also in this way, you fine-tune the process at the start of production. Then someone sends you a different material, and those are the results. So you have a huge and diversity variety of defects on this case. Why? In this case, absorptivity is very different from aluminum to copper, and you have a narrow area where you need to work. And in this area, for a standard machine, it's very difficult to work, because the effect of the material is it's huge. It's a very big parameter. So how you can scale the production, and how you can reduce the scrap material and reduce also the rework time for that. It's the nature of the welding processes. If we are talking about welding, you have a huge parameter that comes and is living with you during processing time, and it's like to drive a shuttle, and you need a very skilled people to manage the manufacturing process, and today you cannot find that. And if you want to send a machine in South Africa or in Congo or in China, you, before send the actual machines, you need to find the people there, or you need to find your technician and send there, but maybe the family are not happy with that. So what we can do? As Augmenta, we develop this technology and apply on different sectors. Is a FPGA controller that gather data from the field using different sensing technologies, drives the robotic work cell or interact with the operator with a smart HMI. But in the back, we have an artificial neural network trained for that particular process. And it's not only a black box, but it's a physical-based model, like a surrogate model, that works. And in every welding operation you made, it takes data and collects data. And every day it collects data. But first of all, you need to get data from the field. For example, to have every time the right distance between the f-theta length or the surfaces of your head to the piece, you need to make a measurement. Or if you want to make a correct path planning of your welding seam, you need to know where is the batteries. Or you want to see what is going on during the welding, to see the depth, the width, if you have splattering and so on. Then you need to train a machine learning model. Machine learning model means that before start the production, you run some tests and you define the curves of your working process, and with that the machine can adjust himself by changing some parameters. Here we have some energy instead of the focal distance to the piece. So only with 2 parameters we can define something on the process. And while the machine is welding, the system adjusts itself. So you don't need to adjust and trigger something because you have made something wrong. In time, the machine is adjusting himself. Then we were talking about the sensing technology to define where the battery is. So is an example. With our generative design software, you make the full point cloud analysis of the batteries before starting to weld. You define all the path to the real battery, not on the CAD model, and with that you can start the production. So every path is different from the other. So every time you make this new analysis and define the new strategy. So in this way you can control everything about the geometrical aspect of the welding. And after that you have defined where the laser goes, but you have to define which parameters of the laser. So here comes up what you have done before to train the model. So you have make some offline analysis. So you have make several tests, cut, and defined which kind of defects are and suggest the ontology for that. And in the other side, you have installed some sensor that gives to you some graphs. And with your analytical model, you define what is going on between them. Then the neural network or the reinforcement learning process start to work, and the results are tune the process parameter. And with that, you have the new recipe for the next welding. And the next welding makes this another test. Obviously, not every time you make offline analysis. We are developing and we are currently deploying our system based in Piacenza, thanks to Lumentum relays. And on that, we are making some experience. And we are currently making some trials for customers to see how can be the throughput of the production with our systems. And we have a scientific environment in Piacenza, so we can easily find and see what is going on in a metallurgic way on the material, and then comes back to the customer and say, okay, guys, this is your the maximum speed, this is the maximum quality, and this is what we expect to get to you for the production plant. We have also developed a smart HMI. This smart HMI helps to sell your machine where you haven't any skilled people. So it's not like an iPhone, but it's very easy to use. You have a real digital twin environment that is working, so you can easily see where is your robot, what is your surfaces, what are the suggested parameters that comes from this artificial intelligence. These digital operators help the operator to select and drive the process before starting. So it's a full digital environment because before go on the machine, you can see what happened in production. For example, if we are talking about robot, we not to collide with the pieces, or we need which is the best strategy to approach the pieces. Today, we develop a different application with our technology. Everything except the Breton machine are visible in our lab in Piacenza. So, for example, if we are talking about cutting and structuring, we use a picosecond laser source and the scanning head, and with this FPGA, we are controlling every time the correct process. Then is another application, just for your information. We deployed and retrofit an ABB robot to make like a big 3D printer. On this bench machine, we study and develop the process and the recipes for the machine learning model that comes on the Breton machine. Breton machine is a very huge 3D printer machine. Is 12 meters long, 4 wide, and 2.5 tall. And that machine runs on artificial intelligence. So the operator don't need to know almost anything of what polymer are used, and the machine selects automatically all the parameters, such as the skew, speed, temperature of the extruder, and so on. And another nice stuff is the robot that on aircraft surfaces see where are the rivets with a combined vision system with a camera and profilometer. Then on this point cloud, define the whole direction, change the tool, take the spindle, win the spindle, remove all the rivets. And this proof of concept, so cutting, the printing, and the rivet removal are POC developed inside Augmented Lab, and then product in scale after. And just a scenario, you have a machine that is driven by artificial intelligence. On the other hand, you have this kind of generative design that allow you to find design alternatives where you'd never think of your own, and suggest to you, okay, if we are talking about supercapacitor, which is the best recipe? I don't know, but there is artificial intelligence that is working for you, and then comes to you with several and multiple solutions, and then you can choose. And I think is the best way to choose instead of design. The same is for the next generation of batteries. We have an interesting case study over there, but I need an NDA signed before talk about that. And here we are. What is Augmenta? In Toronto, where is our headquarters, they are working on digital construction, so generative design for construction. So a software that design where the pipes must go inside the building to, for example, reduce the cost or maximize the maintenance. In Piacenza, we are developing services like the Breton machine, that is this one, or we are making our products. Here is the leadership team of Augmenta. It's important because the main founders are one is Francesco Iorio, is the father of the generative design, and the other one, Max Moruzzi, has scaled the fiber placement for the aerospace sector. This is what the team has made before creating Augmenta. So on one side, for generative design, Francesco designed the way where the computer designed the frame of the car. This was the first car designed totally from an artificial intelligence. No one has drawn one line there. And then with additive manufacture, they realized, or the famous GM machine bracket. On the other hand, we have this strong expertise on fiber placement made for the biggest company based in the US. So this is Augmenta. This is our Maxwell robot that is 10 microns of accuracy. That is our laser-based reference robot. And we are deploying and put in production in several companies. And okay, we are here. Thank you, guys.
Great, thank you, Andrea. Very nice presentation, very interesting, it throws us in the future, this presentation. Any questions? Any curiosities? Antonio.
Thank you very much for the presentation. Just a curiosity, I see in the last slides graphene. Which could be the role of graphene for new battery or energy storage?
Sorry, can you rephrase?
I saw in the last slide graphene. Okay, for the battery. Which could be the perspectives to use graphene for energy storage or batteries?
I think we need a special call for that because it was our scenario 1 year ago, to put graphene on batteries. Then a company asked to make some activities over there. So I don't want to disclose anything, but we can easily set a meeting and maybe go deeper in details for that.
Any other questions, comments? Neither at home. So thank you again.
Thank you.
Davide? Andrea, sorry. Okay, just a brief, quick note before releasing you to the coffee. When we come back after the coffee at 3:30, please, I want to invite the speakers of the 2 days to occupy the first and the second row, because after the 3 presentations from the universities, we will have a roundtable discussion. So if we are a bit near each other, is better, okay? So at 3:30, last part of the day. Thank you.